Good afternoon. I'm Beetle, also known as Don Bailey. I'm a security geek on the AWS Security team. My day job is protecting AWS customers, their data, and AWS itself.
And I'm Brian Wagner. I'm with AWS Financial Services, and I am a security and compliance specialist, which is just like a fancy thing that says I'm helping banks be secure in the cloud.
This is SEC327, AWS Security in your sleep, and thanks for hanging out with Brian and I today. So here is what we will be geeking on. We're going to talk about sleep for security geeks via incident response workflow automation. We will talk about a number of AWS services capabilities that will actually help you make that happen. We're going to present a number of incident response workflow automation examples. We'll go from idea to code to actual execution. We'll have a number of resources to further assist you in getting that well-deserved sleep. And of course, we're going to have some demos.
We're going to have some demos. We want to prove all that stuff to you. We want to show you how it works.
Great, let's get to it.
All right. So for my first trick, we'll go over our first, we call it low judgment incident in terms of incident response. So as we said, what happens when we turn off CloudTrail? Well, we have to turn it back on. So in this case, I've got a CloudTrail right here on the console, and we're just going to go ahead and turn it off. Are you sure you want to stop logging? Yes, I do. Yes, I am. And I'll, in a matter of seconds, I'll have to refresh, of course, but in a matter of seconds, we're going to turn CloudTrail right back on, right? That's part of that containment. Right away, we're going to contain the incident. Let me just do a quick refresh. So CloudTrail is already back on, as you can see, and if we look at time frames here, we might see it in CloudWatch. Let's just or in CloudTrail rather. Let's have a look. We're not going to quite see it in the timeline just yet. It doesn't bubble up. But it doesn't bubble up to the visual log quite as quickly. But the lesson learned here is the event actually does fire in real time. Even though we're not looking at the stop logging call on the screen right now in the event history, that log gets turned on with almost immediately, again, in sort of near real time. So just real quick, we can even do it one more time. Logging is on. We're going to turn it off. Logging is off, and just with a simple refresh, we're going to see that it's already back on. So incident contained, decision is made, and we move on.
Nice. So here's a runbook of what actually happens when we're detecting AWS CloudTrail as being turned off, right? We have an incident response runbook for dealing with that. The first thing that we're doing is we're turning CloudTrail back on. We're going to gather event data that's actually related to this event. We'll also extract the principal, the date, the time, the source IP, other event data. We'll map that principal to a human. We'll look up the human contact info. We'll use whatever internal mechanism we have within our organization, whether it's an LDAP query or a Rolodex. We'll contact that human. We'll provide them with some guidance. And of course, we'll offer them some support. If there's something that they're trying to get done and they need us to explain it to them, we're here to help. And then we're going to generate event summary information for later reporting. Now, it's important to note that we don't actually have to be awake for any of that to occur. I suppose you could call this runbook something fancy so that the auditors are impressed, something like cloud environment logging, integrity, exception, response workflow.
Or CloudTrail off, and that's bad. Maybe that's a better name.
That's a much better name.
It's clear.
I think we'll actually go with that.
Right. So what are we doing? So the first step is fixing the problem, right? Containment. We want to get that containment, that resolution as close to the time of the incident as possible. So those steps could be executed in certain order, but we do want to prioritize the one that actually fixes the problem. So in this case, it's very simple. CloudTrail is off. We turn CloudTrail back on. And in this case, I'm using a Lambda function written in Python, which just says CloudTrail start logging and get the trail name. So for the next piece, which is about gathering evidence, actually those happen simultaneously with CloudWatch events. When the actual CloudTrail gets turned off and that API call fires, you're actually going to get a wealth of information that comes out of that event. So, but the event is the important thing here. So to be able to sort of subscribe to CloudTrail being turned off, you'll see the event pattern there that just is literally looking for that stop logging call. So what that gives you when it does fire that event is a wealth of information, like I said. So that is happening at the same time as the actual, we're going to turn CloudTrail back on, right? So the event that pumps into Lambda that is going to turn that CloudTrail back on has all this information. And you get your name, you get the name of the trail rather, because that is part of the input for the Lambda function, and other things like who is doing it and what time it was, things like that. So in this case, in context of this particular runbook, that name is we're gonna pull that into the Lambda function to use it to start logging again. So now we need to get more information. We need to extract the principal, the date, the time, the source, and so on from the event data. So what we're going to use in this case with that contextual information from the event is we want to actually go back into CloudTrail, the thing that is off now, but it does have a record of itself being turned off. So we're going to get some really cool information. You get the principal, you get the time, you get the IP address, you get a lot more wealth of information. And what's cool about that, again, we're not waking up for this, right? I gave you a screenshot here, but you can programmatically filter for that information right from the Lambda function. You just say, give me the last event where the event name equals stop logging, right? And what the important information we get to see from this is of the role, who actually did it, right? And it does come with the event data, sure, but now we have to dig another layer deeper. A role, some IAM role was the thing that turned it off. So we need to go back and figure out who it was that actually assumed the role, map the principal to a human. So how do we do that? In our sleep, automatically, well, we need to go back to CloudTrail again for another filter. What we want, and that filter there at the top, is we want to see who assumed that role last, or at that time, if you want to do a time-boxed event, if we're looking at this later on or whatever. But you want to see who that was. So now we've got the event, we've got the principal, who in this case was a role, and we've got the human mapped to that principal at this point. Still haven't woken up yet, by the way. So let's look them up. Beetle proposed a really interesting solution if it was Rolodex. So unless you have like a bot, unless you built like an Alexa query or something to look up Rolodex, we're not going to use Rolodex. We're actually going to probably do an LDAP query. It just seems much more practical at that point.
I agree.
Yeah. So now we got to contact them. Now we have their information. We got to offer them support. Was that an error? Did this human make a mistake by turning CloudTrail off, or was it something malicious? So contacting them and offering them guidance, you might be actually alerting them that it happened in the first place and they didn't know it was a bad thing. So it's not so much, hey, you're fired, but it's more like there's a thing that happened, we fixed it, but you need to know about it. And then lastly, we need a summary for ourselves, for posterity, and for, how did this happen in the first place? Did the principal that had permission to do that, should they have permission to do that? So we need to know about these things so that we can improve our security posture later on. So high level, the automation is sort of in this order. Well, not sort of, very literally in this order. So from 1 to 7, gather the event data, turn it back on, right? So of course, again, we want that to be closest in the ordinal operation, the order of operations to be as close to the front as possible. Extract the principal, map that principal to the human, look up the human contact info, contact the human, and then generate that report. So all of those align, those capabilities that we're going to do this in our sleep are API driven and aligned to the services there for each of those steps.
So who here has been a security geek for more than a week, right? You've already seen this nice incident response circle of life where we find out that something happened and we want to establish control over the situation, determine what's actually occurred, make sure that we're getting back to a known good state. We investigate how it happened in the first place, and ideally we're going to put things in place that will prevent that thing from occurring again. But nowhere in this circle of life does it say sleep.
That makes it sound like it's more like an IR hamster wheel.
Right, it's a carnival ride maybe that somebody else chooses for you to ride, and in the middle of the night.
And also blindfolded.
Correct. So we do lose some sleep over security, but that should actually be the exception and not the rule. Security geeks require sleep. And when I say sleep, I'm not just saying Z's, right? I'm not talking about snoozing, certainly not on the job, although it's nice when we actually do get to really sleep. What I'm talking about is time that's not actively engaged in firefighting, right? This is the downtime that's necessary for you to do a whole bunch of other things, all the non-emergent security engineering stuff, right? Whether it's application security, whether it's compliance-related stuff, whether it's threat intelligence. And there's a lot of inventing and building that you would like to do creation of new solutions for your team, for your customers, and you don't do that in the middle of the night. You need to do that when you have the downtime. There's also a lot of learning. A lot of you come to events like this and you learn. And you need time to actually go and do that. Whether it's in training, whether it's in attending conferences, whether it's in researching. And then you take what you learn back to your team and you educate. And that's another non-emergent security engineering thing to do. And then there's non-security stuff too, right? There is the real sleep that we would like to get. We have other hobbies.
Video games?
We'd love to do that.
Yes.
So why can't security geeks get sleep? Well, the pager keeps going off. But why does the pager keep going off? Why are humans being engaged to deal with incident response? Well, most of the time, mitigation requires a human. Or investigation of the event requires a human. Or analysis of all of the surrounding data and correlating that to human activity requires a human. Or contacting a human requires a human. Or writing a report for a human requires a human. But in reality, a human probably isn't needed for all of those things all of the time. So what we're learning about today is how we can put AWS to work for us so that we can get some sleep. Automation of a various security-related workflow is the key to actually getting that much-deserved downtime, the free cycles that you need. You need to look around and find the opportunities to actually automate. And in incident response, there will be candidates that are ripe for automation. You'll have to ask some tough questions, though, to figure out what you will actually automate. Such as, what are the hard boundaries where we can act quickly? Are there opportunities where there's a binary decision, a quick decision that we can make based on a known policy that everybody believes in and we know is the right answer and we're going to go forward with that? Can we make that decision quickly and can we have automation take care of it for us? Do we appropriately assess and assign risk to all events? When we see events come in and we look at them with a human, are we making the same decisions and the same assessments associated with risk for those same events over and over and over? Could we start classifying those? Could we have playbooks where automation classifies, assesses risk, assigns priority? We have to ask another question. What value does a human bring to this particular workflow? If I'm sending an email to another person to tell them about an incident, could that have been done by a robot? Similarly, can I nuke the root cause instead? Am I developing a lot of incident response workflow automation to deal with an event that keeps happening where I should just figure out how to stop that event from occurring in the first place? That'll give us a lot more free cycles. The key thing to hear today is that you're going to have to automate incident response anyway. Security agility, mean time to recovery, all of the things that are going to help you increase your scale, match the velocity of your business, will require you to invest in security automation. So this all sounds pretty familiar. If you've been to a reInvent before, if you've been to one of our talks before, these are things that we talk about. And if you'd like to learn more about some of the things we've automated in the past and some of the tips and tricks that we've given, you can go on the YouTubes and find Automating Security Event Response in 2016, or Force Multiplying Your Security Team with Alexa last year. And in those talks, you'll learn more about detection, logging, automation triggers, rolling back to known good states. You'll also learn about a number of prerequisites, the vegetables that we like to talk about that you should be eating and making sure that you have in place already before you go down the road of trying to automate a number of security-related workflows. So we're going to hit the highlights of some of that previous presentation, and we'll also introduce some new stuff.
And using AWS to automate, we have some really cool services that can help you automate. And I think where the way to talk about this is, yeah, there are cool services, but there's also services that have cool features that can help you along that automation story. Like guard duty, Macy, inspector, these kind of services are sort of more obvious. But it's the supplemental services around that. So you've got config, for example. When Beetle talks about restoring to last known good, well, AWS config literally will tell you the history of the configuration of your environment. So that's a really great place to find your last known good. Of course, Lambda, one of our favorite workhorses to actually execute most of this automation. But today, what I want to kind of elevate that sort of that Lambda discussion or the execution side to a service that is called AWS Step Functions. So just real quick, I mean, these are not brand new. Step Functions are not brand new, but I'm proposing that we introduce them to an IR workflow. So how many people today are already using Step Functions for other reasons or IR as well? Okay, that's good. Yeah, I kind of expected to see that number of hands. It's a pretty popular service. And why, right? So the definition, like anything else in AWS, is JSON. It's nice and structured. You can really finitely structure your state engine or your step function. They're sort of used interchangeably. You can visualize it in the console, so you can see the actual output of that. And the actual individual executions you can monitor, and they light up, green if they're successful, red if they're not. But you can actually see the flow as you move through those step functions to execute those actions and what was the result. You can see the inputs, the outputs, and you can jump right to the logs and so on and so forth. It's a really cool way to organize the steps that we're talking about. A way to execute or a way to structure your runbook. So Beetle talks about eating your vegetables. If this is your first time, that may not be too familiar of a term, but it's really to achieve automation, you have to eat your vegetables. You can't jump right to dessert. So what we're saying as far as vegetables go, it's where does that information come from? What do you need to know in order to have an effective incident response plan? So do you need environment specific or application specific logs in addition to CloudTrail? Those they can go into CloudWatch logs if that's what you need. Do you have the role appropriate in your AWS environment to be able to query for those logs or query for other information? Centralized alerting, where else is that stuff being stored? What else do you need to know? What is the context around some of these alerts and where to get it? Restoring and like backup or versioning. Are you versioning off some of your resources, or are you versioning CloudFormation that you need to go back? Understand whatever your backups are and if you need access to them in order to restore to a last known good state. Bucket logging is true as well. That might be another source of information that is going to be useful to decide, to make choices on how to do stuff. Pre-built IR environments. This is a big one. If part of your IR workflow involves third-party software or your own homegrown software or whatever, that environment should be prepared. It's like a clean room. You need to bring stuff to that environment or whatever the objective is, and that environment has to be there. You don't construct that environment for the first time you have an incident. You're going to want to have that there all the time, as well as the mechanism to get the bad thing over to that environment to be able to use it. Runbooks. You should have a plan, right? And that's what we're proposing. We have the tools to allow you to stitch together that plan to get more sleep. And I think the most important one is practice, practice, practice. That is the most important vegetable. It has the most nutrients for you in this context.
Absolutely. And if you've been to one of our presentations before, you know that we're big proponents of practice. In fact, I think we coined this phrase, and we'll happily say it together and have you say it with us. There are two ways to get practice in incident response, and you get to choose one.
Good, everybody together.
Practice or crazy town, right? And this is me at 4 o'clock in the morning, waking up to a page. Maybe it's you. We don't want crazy town. No. And the way that we avoid that is essentially having the practice in the first place, having the vegetables that we've eaten, having the pre-built IR environments, making sure that we've prepared for that type of event.
So again, back to getting more specific, it's the most important thing about IR is knowing when you have an incident. And so that means you have to know where to look for incidents, right? So you need to know where to look. So I always get asked, okay, now I know where to look, maybe, but what should I be looking for, right? That's basically my rule is I don't know specifically your business objectives or your security objectives, but I always say, if you can get it into CloudWatch, whatever it is, whatever that information source is it environment log, app log, doesn't matter. If you can get it into CloudWatch, and that is either logs, events, or even alarms like metrics, the metrics on resources, then you can detect it, right? That's the whole point of CloudWatch. That's literally the point of the service. But I think sometimes it's unclear as what can go into CloudWatch and what you can do with it. So, because once it's there, you can do really cool stuff like trigger state machines, trigger Lambda, SNS. There's a lot of other things you can do once things are in CloudWatch. But the point is that's a great place to aggregate all this stuff. Macie, CloudTrail, GuardDuty, S3, all this stuff interacts with each other. Flow logs, on-instance logs, whatever. It all flows through CloudWatch if you let it, if you know how to do that and configure it. So what can we do then? Once it's in the execution, we've got from where this information lives. Now, we get it through this execution environment, and then what? What do we do with it now? What can your execution environment provide an advantage to automated IR? It can go back and do some of that reconnaissance, right? We saw in the last demo how we can map a role to a human, right? We have to go back into CloudTrail. We need that execution. If you know what to look for, stop logging. I just want to see the last time that stop logging was called in CloudTrail. That's a pretty easy query. And then downstream, you can do whatever you want. You want to alert? You want to remediate? Do you want to do forensics? Like whatever you want to do, you've got that hamster wheel, right? You keep collecting the information, get as much as you need, and go forth and secure it. That's really that's the end result of all of this is to be able to contain that incident.
And so there are a lot of AWS Legos that we're talking about that you can leverage for security-related workflow automation. And we're focusing on incident response today, but we've talked about before taking an idea that you have and actually getting it to reality, right? And using the platform to do that. There are some questions that you can ask that will help you, that are decision support towards getting you from an idea to code and to execution. And we'll go through a number of those as we've talked about before, such as what is my express security objective in words? Can I actually say what it is that I would like to accomplish? And if I can't, I probably need to simplify that a bit. Is this configuration or behavior related? Because if I can tell the difference between the two, then I know which potential service I might use to support essentially this workflow automation. Configuration related might be AWS config. Behavior related might be something associated with a CloudWatch alarm. Mm-hmm. Where's the data, right? What data is going to support this? Where does it live? And do I actually have the ability to access it, right? Do I have the requisite ownership or visibility within the account where this behavior might be occurring, where the configuration might have changed? What are your performance requirements? Do you need to accomplish something within near real time, 15 minutes, an hour, the day? Or is this something that we can delay until a monthly cycle has occurred? Based on your performance requirements, you'll choose different services and different types of streaming input or static data to support your workflow. And again, now that you've got all of those things figured out, you have to figure out how to actually program it, right? What are the other Legos that you'll need to help support essentially getting this done, and the languages that you'll need? Which SDK are you going to use? Other questions to ask yourself, particular to incident response that we're adding today. Am I done? Are there other rocks to turn over? Is there another road to go down, another thread to pull? Am I done? And does a human need to look at this? And if a human does need to look at this, when is that? Is it now? Is it tomorrow? These are questions that you have to ask yourself that will help inform how you actually automate an incident response workflow. So when we talk about automating an incident response workflow, and we're keeping those questions in mind, we need to be relentless with the automation. We need to get to done, and like all the other questions that we asked before, when we're pulling those threads, when we're turning over rocks, we need to understand, is there something else that I need to do? And that sounds daunting at first, right? But you can actually start with just one workflow, something simple, something binary. So from the moment of that event detection, this simple event that you would like to automate the incident response for, let's start automating all the things. The general things that you will do are get back to a known good state, Get all the logs for the event. Pick out all of the necessary values, the who's, the what's, the when's, and from where's. Make sure that you correlate those values to either personnel or assets. And there's a reason that we need to correlate those values to personnel or assets. Because based on what we know about those personnel or those assets, how precious they are to us, how familiar they are to us, how production-oriented they are to us, will allow us to perform analysis and assign priority from an assessed risk point. And then we'll engage the owners and we'll escalate. If it's an individual that's performing this action and we need to send them a note, then we'll engage with them. If it's something associated with a service team or a dev team, then we'll find somebody that's in that dev team, the manager of that dev team. We'll look for response within a particular SLA, and when we don't get that response, we'll escalate to another individual, right? A higher authority. And of course, we need to summarize what it is that we're getting done. So we'll report whenever and to whomever is appropriate. So if we go back and we look at the first demo where CloudTrail was turned off and we're responding to that, we did all of those things, right? We did all of the things of getting back to a known good state, getting the data that we needed, extracting the relevant values, mapping those to personnel and to assets, looking up contact information, contacting individuals, escalating, and generating report information. So yay for automation, right? Now we can celebrate our robot overlords, but maybe not just yet. If you were just starting on this journey of automating security-related workflows, particularly incident response, then tag. You are still it. You are the automation right now. And so you need to start figuring out where you're going to automate yourself out of that role. Your early automation that you devise, you should probably still run that in a very supervised fashion. So the robots aren't in total control. You need to keep an eye on things. Anything that is a production concern with your automation. Production environments are a high priority. And so they may still be page-worthy for you. You may not want to automate fully there. You may want to escape out and actually contact a human. And so the escape valves that you have to escalate to humans, those are absolutely okay. One thing to remember is that as you're actually performing all of these events and you're summarizing this information, you're creating reports, within the reports themselves, you should have fast feedback loops. These are hyperlinks and/or easy ways for the report reader to engage with that particular event, drill in, get more information if they would like to know more. Because humans, as they're reading reports, and particularly over time, can see patterns that are not as obvious, potentially, to others around us, maybe not the robots. And so if they would like to drill down or they would like to ask a question about a particular event, it should be easy to get access to the event-related data and to get more information. Things to keep in mind. Your automation will break. More complex events and automating those are the reward for your success here. And it looks like we're still going to have jobs for now. So enough of this chit chat.
Let's do it.
Let's get to more of these demos, right?
Absolutely.
Okay, great.
Okay, so in this one, we're going to turn up the complexity a little bit. We're going to escalate the level of judgment to, let's call it, medium judgment. So put bucket policy, as you said, is not necessarily a bad thing. It is if the policy itself is bad. So I've written a little script here that very simply puts an allow all, principal star, so anybody, to do a get object on the particular resource being described in some of the previous API calls. So what this is going to do, it's going to add a statement a statement on the permissions policy, the bucket policy, to allow for the world to get it. If we look at the policy as it is right now, there's some good things in here: require HTTPS, require encryption, S3 side encryption, and allow AWS config to write to it. This is the intended or the known good state. So we're going to use this to get back to known good if something bad happens or if something undesirable happens via this. So let's go ahead and run the execution, which will see the output of the new policy is still the old, encrypted put, require HTTPS, allow config, but also allow anybody to world access to this bucket. So if we refresh the bucket policy, see how fast this thing happens. It's already fixed us, but we're able to see the history of it through step functions. So if we look at the actual step function execution, which ends up being triggered from the rule that matches put bucket policy. So put bucket policy happens, we trigger the state function, and let's have a look at it right here. If we look at the definition of the function, you'll see it's pretty simple. We're going to check the policy because we're going to get the policy as part of that event, and it comes out in JSON. We're going to decide if that policy is acceptable with the Lambda function that does the check. If it is bad, we're going to get that last bucket policy, and then we're going to apply it. So in this case, well, let's look at the execution. Now, there's two of these back to back, and I'll explain that in just a second. But let's look at the initial one. Green, 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 green. Check the bucket policy. Let's look at see if it's acceptable. We're going to see in the metadata here, we're going to actually see the name of the bucket. We're going to see the policy. We're going to get the previous one. We're going to go get the previous bucket policy or the last known good from AWS config. We have a Lambda function that's going to query config and say, with this resource, what was the last configuration? Because that was OK. Now, what I really want to demonstrate here as well is sort of the power of state machine and really the pivotal, the ability for these workflows to pivot. So I have this function called isPolicyAcceptable. It's not a function at all. It's actually, if we look at the code, it's simply what we call a choice, right? It's not calling a Lambda function. We're actually making a choice based on the actual JSON input to that step in the state machine. Because what we're going to see when we do put that last known good state, guess what fires? S3 put bucket policy. We're just doing another put. So that means that event is going to fire. So to kind of prove that our logic works, let's look at the subsequent state execution of that event. What's really important here is that, is the policy acceptable? Yes, it is. It's our last known good. It got there somehow, therefore it is acceptable, but it is doing that check even with our automation. It sort of verifies that the last known good is still good based on our logic that we had before. Okay, so we'll turn it back over and we'll carry on.
So our next demo is looking at a service that we all know and love, S3, and looking for a change in a bucket policy. Now, a change in a bucket policy is not necessarily bad, but we need to understand that change, and we might need to take action based off of it. And so an incident response runbook associated with this particular event would be to understand what happened, evaluate the actual bucket policy, make a decision based off of that. If we need to change back to a known good state, get the last bucket policy, restore that, and then of course, make sure that we're doing the notifications necessary. And again, we don't actually need to wake up in order to perform any of this. So demo,
right.
demo.
We're demoing, I'm demoing, this is the demo, and we are done with the demo. Right, so really quick, high level, the steps are notify, evaluate, decide, and in this case, the point of the demo is that is to demonstrate what happens when it is bad, because it would be pretty boring if it was just a good one and let it go. We want to gather the last known good, restore, and notify. So how are we going to do that? We're going to do that with step functions. So step one is that information gathering phase, right? We have to know that it actually happened. So what you're seeing here is the event, the CloudWatch event rule that's firing the step functions in the first place. So if you look at the granularity of the event pattern, right? It's very specific to that put bucket policy. Maybe I'm not interested in get bucket policy. That's not an event for me. That's not interesting. It kind of answers that question when customers ask, what should I be looking for? Well, in this case, putting a bucket policy could, depending on the results of that bucket policy, change the posture of that bucket, change the access model of that bucket. So that's something that might be interesting. So, and to Beetle's point, not all bucket policy puts are bad. We need to know about it, and we'll decide later if it's a bad thing. But we do want to raise awareness. We want to put that bucket policy through our favorite workhorse, which is Lambda, and that'll kick off the rest of the runbook as discussed. So The part of that event is the new policy. If you remember from the last demo and the results of the last demo, we see that the event that gets sent over to whatever our target is, in this case step functions, actually has the bucket policy in JSON in the event. So we actually don't even have to go back and ask for that bucket policy. Straight away, first function will actually be able to use the information to start diving deep. So the check in this case is pretty simple, shown on the screen here. It takes the policy in, my function takes the policy in, and it makes a check and it decides, it gives us some output. Is it acceptable is the key that I'm using, and that's going to be important because it feeds it into the next step in the runbook, which is decide. Right? The granularity of that particular Lambda function, it just makes that quick decision and says yes or no, and that's based on rules. In this case, the rule is if there is get and there is a star and for the access model, then that's bad. We don't want that to happen. So we're going to return is acceptable false. The power of step functions in this case is I don't have to write another Lambda function to actually decide what to do next. I simply need to make that decision and feed that in a structured way, in JSON in this case, to the next step. And I can actually code up the next step to make that decision. So now, in this case, because the put and the policy was not agreeable, we need to go and restore the last known good. Beetle talks about getting that last known good. Where does that come from? Where is the last known good? CloudTrail, it's a little bit easier because what's the last known good of off is on. So it's really simple when CloudTrail is off. We don't have to really ask about it. We say just turn it back on. But for resources like S3 buckets and other AWS resources, it's not that simple, or it may not be that simple. But with AWS config, it actually might be. So this function, all it uses is the bucket name, right? So the function is get previous bucket policy. Notice the granularity or the atomic nature of that function. On the screen, you can see the next step is actually to restore it. So I've separated out get and restore, right? That Lambda function there, that's the entire thing. It's only a few lines of code. It's got one job. You've got one job Lambda function, which is to get that previous bucket policy. And in this case, it's going to be from config. Depending on the resource, you might have to get it from somewhere else. That's back to eating your vegetables. We have to know where to find it. And all it does in the state, the automation state, is it goes and gets it, and it returns that JSON as structured output for the next function to consume. And it uses the JSON structure, the object structure of bucket.policy.previous. And that's arbitrary. That's what I choose for it to be, because what we'll see in the next function, I'm going to use that same path to go get that last, or to go apply that last bucket policy. So we're going to use, again, a similar convention to input-output processing to get the relevant info, and again, using a very atomic function, which is simply to put policy. If you notice in that function, it's not put the previous policy. It's just going to take two parameters. Give me the name of the bucket, and give me the policy you want me to put. That's its only job. It does, again, we've already made the decisions outside of that function. Why wouldn't we stitch it all in together in one? Well, I'm proposing at scale, you might have that function, that put bucket, or that put policy rather, that might not have anything to do with your IR workflow. It's a tool in your toolkit. You might have some automation on the development side that says, well, when I want to put a bucket policy, I'm going to give it the name of the bucket, I'm going to give it the policy, and send it up to that Lambda. So it's reusable atomic code. And this will work wonders for scaling out your automation. So again, using similar conventions here, I'm passing in this bucket object from one step to the next. And again, all it's going to do is restore. Policy name, which I've got, or sorry, bucket name, which I've got from the previous step, and the previous bucket policy, which I've also got there. And that comes in one input. Very simple operation. And we got that, of course, like I say, from the previous step. Beetle?
So that's one example of a workflow where we're doing something a little bit more advanced than just an on or off, right? We've decided to do some evaluation, assess risk, potentially make a decision based off of that, perform an action, get us back to a known good state, but there's a little bit more judgment involved. And in fact, there's probably a few more roads that we could go down, a few more rocks that we could turn over, threads that we could pull associated with that particular event, such as where was that event performed from, right? The IP address associated with that event might be something interesting to go and pluck, right? And then actually perform an investigation. So there could be things that we would like to do in addition to just the main workflow, right? More workflows and maybe more step functions. So let's take an example of a login potentially to a production environment, right? Where we don't really want that to happen, but we may have a break glass in case of emergency opportunity for developers. And there may be a process where they are allowed to do that, but it's a very heavily monitored, very heavily controlled process. When we see that happen within a production environment, part of what we're doing to check and make sure that that is an authorized action is to get a number of bits of information, such as the user, relevant data, maybe even map it back to a known and open ticket associated with an existing maintenance workflow. And we need to make a judgment call. We need to figure out, does this match our policy? And are we okay with this actual action? And if it's not, we're going to have to perform a number of actions in response to that, such as terminating the actual login session. And we're concerned about that particular instance. So we'll want to isolate that and we'll want to report that. But are we done? There's other things to do here, right? Because once we've detected that this has occurred, we want to get other information about that particular instance, right? We want to pull logs from that, whether it's associated with the application or whether it's associated with surrounding actions in terms of maintenance. We want to correlate all of that data to other sources, and we want to report those findings. Now, are we done after that? I think we might have more work to do, right?
Depends what you find, yeah.
Depending on what we find, we might have forensics to perform, right? We might need to take volatile information from that instance. We might want to gather information of record associated with what AMI it came from. We might want to create a snapshot associated with that environment. We might want to investigate further. And again, we'll have more findings.
Yep.
We'll want to potentially take more actions on those findings.
True.
So we might not be done. But now we've got numbers of workflows, not just a workflow that we're following, and we're chaining those together, and we're using the outputs of different workflows to trigger other workflows.
Right. So we'll let's see that in action. Let's do the demo.
Absolutely.
Let's do the demo. Let's show you how that works. Okay. So for the next demo, this is going to be decoupling some of those procedures. Where we want to get containment when there is an incident. In this case, it's going to be logging into an EC2 instance when they probably shouldn't, or at least not with the right user, if it doesn't match an emergency user username. So we're going to make that judgment call right away. But we're also going to set up for downstream activities, right? Does it lead to further research? Does it lead to forensics? Does it lead to whatever? The point is to be able to stitch these things together rather than have the process be this monolith that you're going to have to keep rewriting and rewriting every time you have a use case to carry out through being done with containing the incident. So our first subject of that is an EC2 instance. I have one here already set up. What's important is the security groups on it. If we view the inbound rules, we're going to see that we're allowed an interactive session, so 22 on Linux Windows or Linux hosts and 3389 from a Windows host. But we're allowing access from anywhere so long as you have the key. So we're going to do that now. Let's go pull up my terminal. SSH. We already have the IP address, so we're going to SSH right into here. This particular instance is configured to send its audit.log, so var log audit/audit.log, which records all the logins, in this case, interactive session. And that's sending, that instance is configured to send those to CloudWatch logs. So the alarm or the metric I'm looking after here is the existence of a session login over an interactive session. As you can already see, I don't know how much time had passed, not much, a few seconds, we actually see a message, intruder alert terminating your session. That was fired from CloudWatch rules, fired from a metric filter on CloudWatch logs that's looking for that event. And what we're going to see in the step functions execution here, we're going to see a couple things. The first thing we're going to do is contain the instance. Terminate the session so there's no longer there. Cut off access to that session. So in the second step, so first one is it an emergency user? The thing you get with that event that we found in the CloudWatch logs is the user, you get the IP, you get the time, and things like that. If I know what my emergency user is, let's say it's called, emergency user, let's say it's called break-glass, whatever the case may be. If that username doesn't match my criteria, I have a decision to make. If it does match it, we're good because it's allowed. If it doesn't, in this case, we need to kick them off and we need to isolate. So step 1, decide if it's an emergency user. Step 2, terminate the session. Step 3, isolate the instance. What does that mean? Of course, we don't want them to get back into the instance. What is the benefit of kicking them off if they can just get right back in? So if we look at our console really quick, a very simple action here is that we've now changed the security group automatically to isolated. And if we view the inbound rules, it has none. Right? There's no more access to this box. We've contained the incident. If we do need to add access to this box for forensics or whatever, that's another process. That's not a big deal. We can do that. So build tag is an interim step to get to the most important part of this, which is tag instances. So tag instances is not forensics. That does not do any more research. The whole point of this is back to that concept of event inception. CloudWatch rules, you can write your own arbitrary event and also subscribe to them. So what I had the workflow here trigger off of is an event called, I'll show you right here, you can see it in the source, ec2.login. I made that up. It seems a succinct way of telling me that the event that has happened here is that someone is logged in. Now, just like the put bucket policy, is that a bad thing? I don't know, we have to check, we have to make some decisions. So where does tagging come in? So tagging here at the end, all we did, we said this is a bad thing, and now we're going to tag the instance after we isolate it. What benefit does that give us? Well, tag instance is an API call. Where do API calls go? CloudWatch. So we're going to actually look for, the next rule in that stream is we're going to look for something called tag instance. And in this case, it tagged it with a couple of interesting pieces of information. And those would be status, isolated, and isolated reason, suspicious login detected. So over in this rule, we're going to see that login, we're going to do the containment, we're going to do the tag, and there's another rule that's going to fire on me tagging that instance or the automation tagging that instance. And it's going to be able to pull what those tags are now that the event happened and go figure them out. If the tag is something bad, we're going to take action downstream, which again, we're starting at the event, just like the login, and you have a workflow. So what do we do? What is the workflow for when something is tagged as isolated? You're going to do recon, we're going to do forensics. You might want to raise another one after recon that says ec2.forensics. And that's a whole other team that's going to look after that and be able to process that. But the whole thing about CloudWatch rules, especially as it relates to leveraging the API, the native AWS APIs for, say, tag instance, is that you can't hide from CloudTrail, because that's where these rules are firing off of, these CloudTrail activities. So get your workflow through CloudWatch and use the event system to build these really complex workflows and ultimately stitch them together. So you can automate until done, done, done. Okay, so very intentionally with that demo, there's a lot of moving parts, right? We've seen sort of, we need to make decisions, we need to automate until done. So we've intentionally broken up the IR workflow to, I'll call them, instead of run books, maybe pamphlets, like just little pieces of the book, right? But the point is you do have to stitch them together. So if you take the same concept I used as far as the granularity or the atomic nature of those Lambda functions from the second demo is to say, just get the bucket policy, a separate function for get and another one for put. If you take that same concept and apply it here, we're actually talking about, isolate an instance. That's got a series of steps in it. So each of those are atomic, but the actual run book for isolating an incident is also atomic. So, because for the same principle, what if you want to reuse it, right? Someone logging into an EC2 instance isn't the only reason that you might want to trigger forensics. So think about all the different things that might result in a forensic investigation. That doesn't mean you have to write the code for a forensic investigation for absolutely every single one of those. You write it one time, and you stitch all this stuff together. So remember what I said before is once it's in CloudWatch, you can alert on it. So if you go back to the YouTubes and look at one of our previous sessions, I talked about this concept of event inception, and that is, these services. This is just a few sampling of the services. These things already emit things into CloudWatch events. These are events that you can subscribe to. I want to know when put bucket policy was called. I want to know when an internet gateway was attached to my VPC. I want to know when someone applies a policy to an IAM resource. All of those things natively bubble up to CloudWatch events. All you have to do is write the rule to match it. So what I'm proposing, you write the rule to match it, and you can trigger those downstream events, right? But where's the rule that says trigger isolation or trigger forensics? That's custom logic. Those are decisions that you have to make and tell the system how to do it. So the coolest part about CloudWatch events is that's an API like any other. And guess what? You can create your own events. So you can bubble up your own events, arbitrary, or in this case, not really arbitrary, but related to incident response, by writing a custom structured event. And then you can write a rule that matches that custom structured event. So that rule up here, ec2.login, I made that up. There's an event I call ec2.login. It's not called login bad, or because we don't know. We have to make that choice. Very much so like the put bucket policy. Just because a user logged in doesn't necessarily mean it's bad. It just means that it happened and we have to make that decision. So how do we make that decision, right? On my step function, my very first function is called is an emergency user. So on the event data that we're getting when the event actually fires, it's being fired based on an EC2 instance log for the audit, for the audit like login trail. So I'm actually looking in CloudWatch logs with a filter that says when this thing happens, I want to raise this event, this EC2 login event. With that event, you do get the actual line item that matched. So in this case, you're going to get a line from the audit.log on the instance. In that line, you get the username. So as soon as that thing triggers, as soon as that event triggers on that login, you immediately get the username and the IP that it came from and is part of that log. That's a pretty good start to make a decision if this thing was bad. So if there is a break glass user on that machine, maybe it has an exact username that we're looking for. That's the logic I applied here. If it's not of a certain username, if it's anything but that, immediately let's terminate. This is a bad thing. This is not intended behavior. So the user login, we decided in the event data if it's OK. If not, in this case, we're going to do the next step, which is terminate the session, as you saw in the demo. We're sitting there, we're interactive, we got the message, and then it went unresponsive because it cut off that session. Then we want to isolate. We want to isolate the instance with a security group that has no rights. So we don't want that user to be able to reestablish the session, right? We're going to contain this thing right away. So then what do we do, right? So containment happens as fast as possible, but then what do we do? What do we have to do next? Well, we have to get more information, right? We have to pull logs, we have to, because we've already determined this thing was bad, but I've got it in a separate run pamphlet, again, if I can coin that. So how do we connect those things together? And also, are we done? Do we need to do forensics? Well, it depends on what we find in the research phase. Right? That happens downstream, going back to one of the principles that we were talking about, which is, what are your performance objectives? Does forensics have to be run immediately? Well, no. If we've contained the incident, not necessarily. That can be another process that maybe you're working on that automation. Maybe that's still human today. Well, that's OK. We've automated down to containment, and we can do that. But we can also automate forensics. So now I've got these 3 separate processes, and we're stitching them together with CloudWatch events. So if you see where on the diagram that event is being emitted, it's at a step on my very first workflow called tag instance. So remember how I talked about if you can get it into CloudWatch, you can alert on it. So just like put bucket policy, just like user login, tagging instances is not a bad thing, right? Actually, we encourage you to tag instances. We can build a lot of automation and a lot of really cool stuff around instance tags, or resource tags for that matter. But in this case, the action I took in my very first run booklet was to tag the instance as isolated, right? We did that after we contained the incident. We terminate the session, we isolate the instance, and then we put a tag on it that says this instance is now isolated. And then we also give it a reason why, right? It's OS login in this case. So there's a CloudWatch event behind that, a CloudWatch event rule behind that says, I want to listen every time a resource is tagged, or in this case, an instance is tagged, because then I can make a decision. What data do we have in order to make that decision? Well, that's the tag where a status equals isolated. If that status equaled, I don't know, give me another description. If that status equaled, fuzzy, or if that status equals kitten, we can ignore. That's not a bad thing. You can call it kitten or whatever you want. But in this case, it says we've got an event, and we've got some interesting information, and that says that this thing is isolated. Now what do I do? That's how we trigger that event. So that could theoretically trigger this research phase. So now we're going to collect more information through a step function. We're going to go get the logs. We're going to go. These are structured logs. We're going to take information from those logs, correlate it with other logs. We do what we have to do in the research phase. But are we done? How do we automate until we're done? CloudWatch events, my best friend. We're going to send a signal out to CloudWatch events that might trigger forensics. And you can do that in a number of ways. You can do ec2.forensics if you want. Again, this is entirely up to you. That's the magic of all this stuff. And then what? After forensics, are we done? Who knows? But the point is, let's say your team is in control of forensics, and whatever happens later is another team. Well, if you can agree on the structure of what that alert looks like, your job as a forensics is during the forensics or post-forensics phase is I've done my forensics and I've raised an event. It's up to that next team to consume that event and do something about it. So that's how we're going to chain together these processes that can be reused. So whatever is happening in the forensic side, like I say, there's tons of ways to invoke that. If the forensics team was just looking for ec2.forensics, well then think of all the different ways you can get there, right? It's whatever you want to do as long as you agree on that structure. So in this world of separate runbooks and separate, these divided operations, how do we wrangle it all, right? We still need to know about it. We still need to research it down. We still need to learn from every single one of these steps. And we need to learn from it. We need to improve our own security posture to make sure those things don't happen again, or take great measures to make sure those things don't happen again. So we have to tie it all together. Hopefully, we're doing this with a Security Incident Event Management System, or SIEM, I don't know how to pronounce that. Hopefully one that is API driven. So the one I'm using here in these examples is a product called Incident Pony from Ephemeral Systems. And what I like about that is it's API driven. Every one of these little atomic workflows, every one of these little run booklets, it can, on the notification phase, in this case, instead of notifying email here and that over there, it's sending an API call to my SIEM, and we're able to holistically see that end to end, no matter if it's this process or that process, whether it's the login break glass or it's forensics. Sending it up with an API call on this automation-driven workflow, it can tell us a whole story at the end, and we can actually track that thing to resolution. We know how that worked, even though these moving parts are all in different parts of your strategy. So you're not alone, right? All these different functions, all these different ways to tie these things together. You're not alone. We have a great partner space and technology partners that are very cloudy, right? They offer up those APIs. They give you that top level visibility that you can just throw so much information up there, whether it's an event itself, and what Beetle was talking about is getting that access, the information around the event itself, making that super easy to be clicked or accessed right away. Some of these products can actually do that. So instead of going back to S3 for the logs, just take the log and pin it up there and throw it up there, and it's all in one place for you. So check those out, but you got to have a plan, right? Which one of these do I use? It depends on your plan.
And then if you're looking for open source incident response solutions, there are a number of those already available specific to AWS as well. So AWS has a number of security automations. There's more that we're releasing this week.
That's right, yeah, that's right.
Threat Response is a good open source project associated with forensics and AWS environments and automating that, whether it's for one instance or 10 instances or 100 instances at a time. Weza now has integration with AWS as well, or supports AWS. Our customers have a number of open source incident response solutions that they have published as well, and those are available now. If you look at Cloud Custodian from one of our customers, Capital One, that's a great resource for you. Fido and SecurityMonkey from Netflix, a number of other open source projects that are available. And the Netflix security team, absolute rock stars, and they're putting out open source code for you to help with security related stuff in your AWS environment. And Airbnb has Stream Alert, which is another open source project associated with security and automating those workflows. Now, if you're looking for community or industry related resources, check out FIRST. It's the Organization for Incident Response. And they have, whether it's online documentation as well as events where they have training, and AWS actually shows up at those events, and we provide training at FIRST events as well. And then now there's documentation actually published. Cloud.gov documentation and incident response that actually speaks about or speaks to the cloud. Knowing that there are customers that are using cloud environments and that incident response is not necessarily unachievable in those environments, it's just different, right? And now we have documentation that actually speaks to that. So check out cloud.gov and their documentation for security and incident response, which now has a number of updates associated with cloud. We have documentation online already. If you're looking for a starting place to building a cloud-specific incident response plan, we've already published that for you. And while we were publishing it for our worldwide public sector customers, it's certainly relevant for anybody else that's in the commercial sector as well.
And if you stay tuned to that same security blog, I'm going to release some of the distilled version of this session, or at least the code behind it, the concepts behind it, on the security blog. So keep a lookout.
And we mentioned previous presentations that we've provided. Those are on YouTube. You can search for incident response in AWS, and you'll find a number of YouTube presentations where we've talked about security-related automation. If you're looking for training in security operations and specific to an AWS environment, we provide that now. And so you can go onto our website, you can search for security operations on AWS, and you can click and find where there's training near you if you're not taking training here at reInvent. Speaking of interesting training at reInvent, which is a lot more fun than I think of than other training, is our Security Jam. Our Security Jam is a defensive capture the flag event where you, as an individual or with teammates, can compete against other people, humans, yes, not just robots, and even find automated ways to solve a number of security-related events in an AWS environment. And you don't have to actually be at the Security Jam.
That's right. This year, for the first time, we were able to launch a virtual jam or a virtual lounge. So if you go to the Expo Center and go to the AWS area, you can actually get credentials for this week and just to actually do this at your leisure at your own time. And then through AWS Professional Services, we can actually test your mettle. Like if you figured all this out and you say, yeah, I hear what these guys are saying, either I agree or I don't agree, and here's my solution. You can actually contract AWS Professional Services to come in and run game days to see how effective it really is.
And then of course, we always need to point out that support is your one-stop shop for getting the help and assistance that you need associated with any events that you have within your AWS environment. Feel free to reach out to support when you have a question. Whether it's something that you've planned or something that's unplanned and you need some assistance, support's going to help you. They have their runbooks to help you. And if they don't have an answer for you in their runbooks, they know who to escalate inside AWS, particularly the AWS security team, if it's a security-related concern that you have.
And for other related talks, check it out on Tuesday, we've got 5 new security automations. So if you learned 1 or 2 new ones today, you can go in 1 hour, learn 5 new security automations. Wednesday, you can see how AWS Lambda is part of your security team. All right, so going back to the automation story, very, very effective. And last on Thursday, Netflix, right? They are, like Beetle says, describes them as sort of security rock stars. They are indeed. Go check out their session on forensics, and they do very, very cloudy things with forensics, and it'll sort of modernize the way you think about forensics.
All right, so summarizing the takeaways for you to go back and share with your team. Security geeks can absolutely be heroes, but they shouldn't have to be heroes all the time.
I have a cape.
Hey. Automating incident response workflows are going to free resources, right? So that you can perform some of those non-emergent yet very important security engineering tasks. AWS capabilities are going to be the key to helping you create end-to-end automation for those incident response workflows. Hopefully you've seen how to do that within this presentation, but make sure you go and look at all the other different things that we've talked about in previous presentations to help spark those ideas. And remember, start small, start simple, iterate from there, and make sure that you leverage our partner or open source resources as well as support to get you to the right place that you need to be. So thanks a lot. That's it.
Thanks everybody. Thank you.